lecture about process management, that is how a process is managed in the operating system. So to understand this process, we must be able to understand the difference between the program and process. So a process is a program in execution. For example, when we write a program in C or C++ and compile it, the compiler creates binary code. The original code and the binary code are both programs. When we actually run the binary code, it becomes a process. So this is what we call it is the actual meaning of a process. Now a process is an active entity instead of a program, which is considered as a passive entity. So program is our passive entity and process is the active. A single program can create many processes when run multiple times. For example, when we open .exe or binary file multiple times, multiple instances begin, means multiple processes are created. Now the next thing is process management. Now if operating system supports multiple users, then services under this are very important. In this regard, operating system has to keep track of all the completing processes, schedule them, dispatch them one after another, but user should feel that he has the full control of the CPU. Now, what does a process look like in our memory? This is how a process look, and this is how the whole process is managed or organized in our memory. So in this, we have four sections, that is text, data, heap and stack. So in the text section, if we talk about this, a process, sometimes known as the text section, also includes the current activity represented by the value of the program counter. And in the stack contains temporary data such as function parameters, return addresses, and local variables. In data section, it contains the global variables. Heap section dynamically allocated memory to process during its runtime. So this is the different types of organization, different components that are arranged in our memory and that makes a process. Now the next thing is states of the process. Now a process is in one of these states. These states are first of all new. So a new state means newly created process or being created process. Then we have the ready. The ready process means after creation, process moves to ready state. That is, the process is ready for the execution. After that we have run. Currently running process in CPU. That is, only one process at a time can be under execution in a single processor. After that we have wait. In wait or block, when a process requests input output access, means when a device or when a process wants some input or output access from the input output devices, so this is a state called block state. After that, suspended state. Suspended block means when a waiting queue becomes full. And suspended ready. Suspended ready means when the ready queue becomes full, some processes are moved to suspended ready state. And we have one more state called terminate. The process completed its execution. So we have these states. First of all, we have create, then ready, then it will go to the run state, then it will go either to the block state or either to the terminate. Terminate means it has fully completed. After block, it can be go to the suspended states. Suspended are of two types, that is blocked and ready. This was all about your states of different states that are included in a process. Now we have a different term called context switching. Now what does this term means? The process of saving the context of one process and loading the context of other process. This is known as context switching. In simple terms, it is like loading and unloading the process from the running state to the ready state. And when does this context switching happen? When a high priority process comes to a ready state, that is with a higher priority than the running process, or when an interrupt occurs, or the user and kernel mode switch, that is, it is not necessary though, but it can happen, or preemptive CPU scheduling used. So these are the conditions where context switching will happen. After that, we have multi-programming concept. So what does the actual meaning of the multi-programming? We have many processes ready to run. Okay, so this is the multi-programming, means that we have many programs, we have many processes that are ready to run. And there are two types of multi-programming, that is preemption and non-preemption. In preemption, processes is forcefully removed from CPU. Preemption is also called as time sharing or multitasking. So this is a process in which all the processes forcefully removed from the CPU, and non-preemption means processes are not removed until they complete the execution. Then we have degree of multiprogramming. Now what does this mean? The number of processes that can reside in the ready state at maximum decides the degree of multiprogramming. Example, if the degree of programming is equals to 100. Suppose we have degree of multiprogramming as 100. This means 100 processes can reside in the ready state at maximum. Okay, so this was all about your process, its different states, multiprogramming concept and degree of multiprogramming. Now that's all for this video. See you in the upcoming for more details. Thank you, and don't forget to like, share and subscribe the channel.